everyone for coming. My name is Lars. I'm the founder of a startup named Scling. We do something called data value as a service, and I'll explain in the end what that is. It's easier if I get to show you a few slides first. Today the topic is reproducibility in data science. I'm not a data scientist, and this is my first time on this conference. But I hope to give you a slightly different angle on data science and reproducibility and efficiency in data science. I have seen a number of organizations like adopt big data, adopt data science and data engineering, and a common pattern is that some data scientists are hired, they are like put in a corner, they get some data, they usually have at the beginning very little support from engineering, very little support and connection to the product and to the business. You get some people to export data, you do one-off export from databases, and they get to play with that fixed amount of data in a corner. From a reproducibility perspective, this is great because you have the same data all the time, so your experiments are reproducible. Now the drawback is that you will end up like overfitting on this particular thing of data, even if you do use your best practices and do test data and so forth, you will manually overfit your hyperparameters to the data that you have. The data scientists tend to use notebooks. That's one of the popular tools out there. I guess most of you use them. They are great in a limited scope. They are excellent for storytelling, showing things with data, for playing around with things and so forth. You know this. I don't want to discourage you from using notebooks. I want you to be aware of their limitations, however. There are issues in the implementations in the notebooks with respect to reproducibility. So if you change things in the middle, you might think that they run from the beginning and do something predictable, but that's not always the case. And they are not a great environment for collaborating between multiple people or for putting things into production. I won't go too deep here, but if you're interested in the subject, I encourage you to look at this presentation linked here by Joe Gruss. I don't like notebooks. He is a data scientist, unlike me. Again, not to discourage you, but to be aware of the limitations. So the next phase that I see organizations go through is that the data scientist in the corner either go fed up with not being connected and not producing any business valuable results and they quit, or they get somehow integrated and get support from engineering. They might get onboarded onto the data platform so that they can use the data in the data lake, they can deploy pipelines with engineering support and so forth. And now you move to a bunch of static data to be able to use flowing data, use experiment on flowing data, experiment on the not 3 months old data, but the latest data from yesterday. So this is great, and you can train on more data. What data do you train on? Well, you train on all the data that you have, of course, which is different every day. And you evaluate your model on all the data that you have, which is different every day. So it means that your results are more relevant, they're fresh, but they're typically no longer reproducible. So the data changes every day, and some of the workflows and the tools that data scientists are used to use have in practice resulted in a culture and habits that do not yield reproducible experiments. From a science perspective, this is kind of odd because scientific means like being very precise with the methods so that you can reproduce them and draw strong conclusions from them. So data science has become this old thing with data science, which is like data tinkering, but without all of the scientific methods. Now, I don't want to crank down on data scientists because we have this sister activity called data engineering or data unengineering, which is like tinkering with data but throwing out all of the good practices of software engineering that we know since decades. I'll give you an example in a minute. This is a conversation that I had in 2013. That's when I joined Spotify. Spotify are the leaders in Sweden in terms of competence in data engineering and data science. And this was how we used to go about when we had an idea, we wrote some code, and now we wanted to test this. There was no test environment, there was no testing in the idea. You just throw it out in production and see what happened. And if you remembered to change the path so that you wouldn't overwrite the production data, that was a good thing to do. Otherwise, you would wreak havoc. Now, shortly thereafter, we managed to do a transformation to establish Devops practices, and I'll tell you about them a bit later. So, after the flowing experiments, in order to actually connect your data science to real business value, you need to get the models out into production and affect real products. And the first time you do that, it's highly unlikely that the models will be of any use, because this is a very much hit and miss activity. It's difficult to get things right. There's a rule of thumb that if you work on complex IT products and you have an idea, there's a 10% chance that idea is good. There's a 30% chance that the idea is actually actively harmful. So you need to experiment and iterate. And this is what the flow looks like in data mature companies. The data scientists are integrated with product teams. They tinker with the models. They evaluate them in production through A/B testing or through dry running or whatever. Now, reproducibility starts to become important, because the first ideas that you have, the ones that are good, you will get significant gains. But after a while, you will get diminishing returns, and you will get smaller gains. You will get, instead of 10%, you will get 1% or 0.1%. And if you measure and you get to a 0.5% improvement, is that what you did, the change that you did, or is that a change in the data? If you cannot reproduce the experiment, you will never know. And the quicker you can reproduce, the better. So you need to get this reproducibility in control, or you will grind to a halt in terms of innovation. Now, reproducibility is in theory, a technical thing. There are a couple of technical things that you will need to master and get right. You will need to train and evaluate on a fixed set of known data. That amount of data cannot be volatile. And that seems like an obvious thing when I say it to you, but I've lost count of the number of data scientists that just say, oh, we'll go into SQL or MySQL or BigQuery and take whatever latest data that we have. In order to have control over which data you have, there's a tool called workflow orchestration that you need to master, because that enumerates the data and keeps track of them. I'll show a display later. And you will need to train and evaluate on batch data, because streaming data is per definition unbounded and per definition not known. There are typically randomness in the models. Ideally, you would have no randomness whatsoever. Unfortunately, many machine learning models depend on some kind of randomness, so you have to have randomness, but control it and keep it limited. So I predict that if we go into the future, 5, 10, 20 years, and look back on the data science that we do today, we will be astonished how we got anything done, how we got anything out into production. It typically takes months or years for large corporations to get into production. The other day I saw an interview with one of the large Swedish companies, and they were very happy because they had, after 9 months, come to production and saw that as a success. Relatively speaking, it actually is. There was a couple of years ago, the Dutch Rabobank, one of the major Dutch banks, they came to a conference and they said, well, we had this big data project, and after 2 years, we got the first pipeline in production. Then they came back the next year and said, now we have 3 pipelines in production. The team or the companies that are data mature and know have a grasp on how to work quickly with data. They have cycles of days or weeks instead of months or years. So these are all things that we tend to do as data engineers and data scientists when working with models. Like what was the data that we used? Well, what's the script again? And you have linear script for building your models and so forth. Now, with time, we will get out of these practices. And the good news is that all of these problems are already solved. We can just look back a couple of decades at software engineering. Data science today is where software engineering used to be in the 90s. Now, younger parts of the audience probably won't believe older people when they say that, we didn't have version control. We used to mail the files around, right? And I would ask somebody for a file and then get the DLL, and then I would go off to the dedicated build machine, and then I will build the blessed build, and that will go into production. I see somebody nodding here in the front. So software engineering used to suffer from all of the issues and the problems that data science are suffering from today. Which means that we can learn, like we can pick the things that have plagued software engineering and try to transfer them and adopt them in data science. There are 4 things that I would like to highlight in this presentation that I encourage you to adopt or pick up. There's the Devops transformation, which is a more of a human thing than a technical thing. There's the practice of having everything as configuration or code checked into version control. The habit of building immutable artifacts directly from source, not from intermediate results, and then get continuous delivery and continuous integration going. I'll go into some detail or explain a bit deeper for each of these what I mean. The Devops transformation is basically an organizational transformation, even though there's a bunch of tooling connected to it as well. There was a realization that if you have the development teams here, they throw things over the wall to the QA people here, and they throw things over the wall to the operations people here. That is very slow because your business value is aligned through multiple teams. So if we just make these people work together in the same team, we can be much quicker. We have the same now in data science, where the data science, they write models in R or Python something, and they throw them over the wall, and the engineers, they say, oh, I can't touch this, I'm going to rewrite it in Java. And then they throw them over the wall and put it in production. And then the data scientists say, hey, we've tweaked our Python models a bit, and everything becomes very slow. So form cross-functional teams and align your teams with a business value. And that is known as that is part of sort of the DataOps movement, which is not the same thing as the DevOps for data, but it has a lot in common. There's the building immutable artifacts from source, right? My dad was into programming. He has written Fortran things. And his colleagues, they used to remember what compiler commands they would type down and remember all of the compiler flags. And then they graduated from there to actually having like bash scripts, which did all of the compilations. And now, of course, nobody will use a bash script. We have build systems for these things. It's a completely obvious thing. No one would ever consider building today with bash scripts. We have build systems to handle the dependencies and so forth, right? And we have learned that we should not, once we have built things and deploy them on computers, we should not go out and mutate them. They should be immutable so that when we need to deploy something again, we build a completely new image and we deploy that one. And these deployment artifacts, they used to be binaries and Java files. Now we know that it's better to have container images because they contain everything that we need, almost everything at least. So if you go to data science job interview 10 years from now, and they ask you, how do you build your models? Well, I have this Python script, and it trains on all the data, and they will say, there's the door, right? But today, this is what we do. This is what almost everybody does. The build system for data is called the workflow orchestrator. There are two of them out there that are good. They're called Luigi and Airflow. Pick one of them up. This is, if you only remember one thing from going to one of my talks, is master workflow orchestration. That is the key to being effective, both as a data engineer and a data scientist. Your flows should be hermetic. They should not get any information from the outside, only from the source data that you have, your code, which is checked into version control. And there are no good toolings here, so this is something that you manually need to keep track of, right? You shouldn't query live databases. Don't go to Redshift or BigQuery. Use only the data sets that you know. Otherwise, you'll break reproducibility. We have learned in software engineering that we should not have like volatile operational state out in the systems. We should not do operations by SSHing to different machines and changing their state. We should have their definitions, both for the state of the machines and for the infrastructure itself, now that we have clouds, in version control. And we should push that out so that we say, I have this configuration, please make my infrastructure, my deployment exactly as this configuration. Right? It took a long while for us to realize this. One thing annoys me really about this movement, and it's the fact that we chose some really bad languages to represent this. Both YAML and HashiCorp language for Terraform are popular, but they are very, very limited. Now, as data scientists, don't make that mistake. You have a fantastic language called Python, which is highly suitable for these things, so stick to Python. Don't let any engineers tell you to write YAML instead. We can do the same thing for data science, check in everything into version control, everything that you use for testing your models, the test data. I know Git is not very great with data, but there are other ways to check things into version control. You might think that testing data science and products and machine learning models is significantly more difficult than testing like a bookkeeping application. That is true because machine learning applications are fuzzy, and there's a challenge here in testing them. That problem was solved long before data science, however. We've had search applications, map applications, and all sorts of fuzzy applications testable for decades. So there are known tricks in software engineering to solve these things. Many of you have seen these pictures. It's from a brilliant Google paper called the Hidden Technical Depth in Machine Learning Systems. The size of the boxes is the effort in person hours that are being put down into machine learning products. And this is not just somebody's opinions. These are measured sizes. Right? And the color or the shade is the complexity of the model, or so complexity of the code. So the machine learning piece, the machine learning models are in the middle. Little effort there, but lots of complexity. Everything around takes much more effort. This means that if you adapt your tooling completely after the machine learning things, you are going to down prioritize what you spend more effort on. So your tooling and your workflows and so forth have to be in coordination with the rest of engineering. So I often see many of these tools, like here's a machine learning deployment specific tool and so forth. I'm not a big fan of those tools. I'm a fan of the generic tools because they can typically handle machine learning challenges or machine learning products fairly well as well. The continuous delivery took a long while as well to land in software engineering. There were a couple of factors that held us back. One was the assumption that if you have software products that are really, really important in terms of reliability or availability, you cannot deploy quickly because that will give you worse reliability. This book and the connected report, which is called State of DevOps, are fantastic reading. I urge everybody to read them. They have measured aspects of reliability and speed in various companies and concluded that there is no trade-off. So the companies that manage to operate with the highest reliability are also the one that manage to deploy fastest. So all of the work that you do to deploy faster will actually, in practice, help your reliability. So, getting this, closing this circle and getting continuous delivery for machine learning is even more important than for standard products, because you have this challenge that you are, when you're building machine learning products, you are much more trying and fumbling, and you need that swift feedback in order to build great products. As mentioned before, the companies, the large companies and the enterprises, they have cycles here of months or years. And what's holding them back is usually cultural aspects, getting the right people to work together, getting new workflows in place, and so forth. Once you work with the culture and get it down to a month, this month is actually also not a made-up number. It is a measured number that we did at one point at Spotify when we felt that it was doing this whole cycle was too slow, so we did a measurement, and it took a month to log something new from the client and to get it into a data pipeline and get it out. But then once you reach that stage, there's a lot of technical work to get you down to the lower numbers. After the Devops transformation that we did, we actually got it down to less than a day to deploy a new pipeline in production. And there were other teams working with things like A/B testing frameworks so that you could be very, very quick and have new machine learning ideas out there in days and tested in production on test groups and so forth. One other thing you can do is you just skip the first 2 phases of data science in your company. To be honest, they don't really add any value. I mean, there's some learning in the process, of course, but they will also most likely get you into bad working habits. So as soon as you get data scientists into your company, go put them close to production teams. If you are data scientists, seek production teams that add real business value and work closer to them instead of in a safe corner somewhere. And the way to get all of these practices from software engineering and get them into data science is to mix people. So there are technical things to do, but in the end, you will only affect practices and workflows and teams if you mix people with the right competence in. So try to get senior software engineers that have seen a few phases of software engineering into the data science teams. As data scientists, you will think that they work differently from you. And it's both sides here need to be very mutually respectful, because these software engineers come with a bunch of practices that eventually data science will pick up as well. So you might as well try to identify them and pick them up. On the other hand, if you send software engineers into a team and they say, well, scrap all of your practices, now you will be forced to use Java and Maven and so forth, and the data scientists will quit, right? So there's a middle ground somewhere. So in the end, solving reproducibility, which is a technical problem, doesn't have technical solutions. It primarily has human solutions. because many of the technical solutions are already out there. I recently watched this presentation on a similar subject, which is also a great watch. The slides will be available after the presentation, so you can watch them. So now, who am I? What do I do? Well, I learned the trade of data engineering at Spotify a number of years ago, and I rolled out a generation of their data infrastructure there. Nowadays, I have founded a startup, and we are providing this thing in the green box as an external service for companies that are not highly technical. So we're providing the same technical solution, the same workflow solution as the highly technical companies, but to companies that do not have IT as their core business. So if you want to learn more about data engineering, I will be holding a course next month, so just reach out and contact me if you would like to go. All right, thank you very much.